Now we are going to take up the physical properties of the alcohol. As you all are familiar that what are the methods actually which we can use to prepare alcohols. So now we are going to start with the physical properties. So the first physical properties you would like to know that how, like what is their existence at room temperature. So if we talk about lower members of alcohols, that is methanol, ethanol, likewise that means which contain the less molecular weight, they are actually colorless, volatile, they can escape actually, and they have an alcoholic odor, and even if we talk about taste, they have burning taste. But the higher members, they are waxy solids. So as you can see that the lower members I told you is in volatile, so that means they contain the less interaction between them, less attraction between them. But in the higher, as they are waxy solids, so that's compared to it possesses the more forces into it. That must strike your mind just looking at that what is the state of existence of lower alcohols and the higher ones. Second is the boiling point. If we talk about the boiling point and if we compare it with alkanes, why am I comparing with alkanes? The reason is that because after replacing one of the hydrogen we get alcohol, right? Like if we replace one of the hydrogen of alkane, we get alcohol, respective alcohol. So like that is the reason actually I am comparing its boiling point with the alkanes. So if we compare the boiling point of alcohol with alkanes, it is higher. Now the higher means, higher indicates that there is more interaction, there is more attraction actually. So what are actually those interactions? One is the intermolecular hydrogen bonding. As like when we see alcohols, what we see is they can actually form the hydrogen bonds, as I have drawn it for you. See, this is my alcohol, one molecule of alcohol, this is my another molecule of alcohol, this is my another molecule of here, and as you can see the O of one and the H of the other, they are just linked with each other, and these are nothing but the hydrogen bonds. So that means hydrogen bonding, because due to the hydrogen bonding they can form, and as such in alkanes we do not see that kind of hydrogen bonding because there is no O present. So that means in this case there is a strong hydrogen bonding and it is absent in alkanes, and we know that it is actually the bond between C and OH is polar 2. So that means it has a partial negative and a partial positive charge. So that means they somehow have more attractive forces if we compare it with the alkanes. So due to which the boiling point is generally higher. But there we see actually a variation with boiling point. Boiling point actually increase with molecular weight. Like if I am talking about propanol and I am talking about heptanol, so obviously heptanol is going to possess the more the boiling point. The more boiling point means more attractive forces. More attractive forces means there will be more you can say the more hydrogen bonding will be there, right? So that is the reason actually we get to see that with increase in the molecular weight the boiling point actually increase. But if we talk of branching, suppose I have let's say this kind of alcohol, I have this kind of alcohol, I have this kind of alcohol. So this is my primary, this is my secondary, and this is my tertiary alcohol. So if we talk of branching, like if you talk about the branching, because here the difference is that it is 1 degree, 2 degree and 3 degree, likewise you have the branches actually. So with branching what do we observe? We observe that the boiling point actually decrease. Boiling point actually decrease. What happened actually? The branching means more compactness, and when there is more compactness, it leads to decrease in the attractive forces, and when there is decrease in attractive forces, that means we need to supply a less amount of heat to boil it. So that is the reason that the boiling point actually decrease with increase in the branching, right? Third, we are talking about the solubility. Solubility particularly in water. So what happens, generally we see that lower alcohols are soluble in water, and you know that the criteria for solubility in water is that whether a substance can form a hydrogen bonding with the water or not, right? This is only the basic criteria. So what we have seen that when we add the lower alcohols to water, they are able to form the hydrogen bonding. There is an hydrogen bonds form actually, and that is why they are soluble. But when we talk of the higher alcohols, that means the alcohols with higher molecular weight, what we see is that solubility decrease. Now what is the reason behind? See, suppose this I have ROH and this is my R dash OH. Let's say this R comprises of 2 carbon atom and this R comprises of 7 carbon atoms. So what is going to happen here is that this is going to get soluble in water, as this R is not going to restrict this OH in being into hydrogen bonding with water. But as we see for the higher alcohols, what we see that this hydrocarbon chain actually dominates over this thing OH, this bond, and or you can say this just dominates over the polarity character, and this restrict the bonding of this kind of thing with the water. So that means there are no means a less hydrogen bond is formed with water. So that is why the solubility actually decrease when there is an increase in molecular weight. The simple reason is that as there is an increase in number of carbon atoms, they just dominate over that polarity character and restrict the formation of the hydrogen bonds. And solubility increase with branching actually. What happens when they are branched means they are closer to each other. When they are closer to each other, that means the surface area for the hydrocarbon chain gets reduced, and it somehow allows the hydrogen bonding to occur. So that means branching can actually increase the solubility in water because more hydrogen bonds can be formed. Next is density. It is less denser than water. If we compare its density, it is actually a less denser than water. And it too have intoxicating nature, as you all are familiar that alcohols are actually the components of the hard drink. They have a sedative effect on us. That means it can suppress the activity of the nervous system actually, and that is why you can say that it is somehow intoxicant in nature. And you know that methanol is a type of alcohol which is very poisonous. It should not be consumed. Even this methanol is actually used to denature the alcohol. Like whenever in the industry we are using alcohol for certain reasons, we know that there are workers and they know that alcohol has a sedative effect, so they may misuse that alcohol. So what we do is we make that alcohol denatured alcohol by adding certain poisonous substance, and one of that poisonous substance is the methanol. Methanol itself acts as a poisonous substance which is used to denature the alcohol. And you know that if methanol is consumed actually, it can cause the blindness and even it can cause the death. So that means the alcohols are actually intoxic in nature. That means they have a harmful or adverse effect on our health, so they should not be consumed or should be handled in a proper manner. So these are actually the physical properties. This physical property which I discussed with you, that is the boiling point, the hydrogen bonds, the solubility, how it varies, they are very important, right? So just make use of certain examples, like if somebody asks you that how boiling point decrease with branching, so it's not a reason that you should write only 2-3 lines and cover up your answer, right? You have to illustrate your answer with an example, make a primary kind structure, secondary and a tertiary, and then just write few lines about it, that yes, you can see that here the branching is increasing, they are more compact, and more compactness means there will be less attractive force. So just try to illustrate with an example, that's it. So these are actually the physical properties of alcohol. So now we are in position to start with the chemical properties. So look at the board carefully.